A cube of side 60 mm is resting on HP on one of its corners, resting on HP on one of its corners, resting on HP on one of its base, on one of its base, with one of the vertical face inclined 40 degrees to VP. Inclined 40 degrees to VP. It is cut by a section plane. It is cut by a section plane perpendicular to VP and inclined 45 degrees to HP. Let us take in problem, we just take it as 40. Let us see what happened when it is 40. Inclined 40 degrees to HP, passing through a point passing through a point 40 mm on the axis, 40 mm on the axis above the base, above the base. Draw the projections. So draw the projections means in the sections of solids. So it is nothing but draw the, let us see, draw the projections. Projections of sectional top view, gamma front view, and true shape. All of you kindly note this problem. I just had to erase this problem to do, so space is not sufficient for me. So the top space I required. So all of you just note the problem. I just erase the problem after all. So a cube of side 60 is given, is resting on HP on one of its bases with one of the vertical face inclined, 40 degrees to VP. So directly you just take its cube of side 60 with one of the vertical face. Let us consider if it is going to be resting on like this, means vertical face is going to be, these are the vertical faces. These are the vertical faces. He is going to be inclined 40 degrees to VP. So this face inclined 40 degrees to VP. So that means this vertical face is going to be resting on the axis line, which is making an angle of 40 degrees. So and it is cut by the section plane perpendicular to VP. So first of all, here it is going to be vertical face inclined to VP. Vertical face is inclined 40 degrees to VP. So which gives the true shape? When your vertical face is inclined Okay, when your vertical face is going to be inclined, this vertical face inclination is going to be seen from the top view only. When you are supposed to see from the front, you don't see how much it is going to be get inclined with horizontal. So when you can see it is possible on when you are going to be seen from the top, you just see this is going to be making an inclination of 40 degrees to the VP. Okay. So this is not space. I am erasing the problem, all of you. Students, I just erasing the problem. Okay. For my sufficient space. So stage 1 is going to be same. Stage 1 is nothing but your simple position. How can you put your simple position? So which will gives the true shape. So that we have to start from it. Okay, the axis is going to be perpendicular to HP. So let us see the given data. Given it is Q side 60 mm, vertical face inclined 40 degrees to VP. Okay. So draw a line of 40 degrees. Such that this becomes your vertical face. Okay. So let us put the points A1, B1, C1, D1. So in bracket it is P1, Q1, R1, and it is S1. Okay. And you just take your axis. So I just draw this for my reference. Once you just get the axis, you just erase this. That nothing but your origin center point. So this becomes O1 of O2. Okay. So what was the height? We already know the height is given 60. If I increase the height, it should be. Height is also as same as the side. $60. So when you are supposed to see from the front, so at on XY you are going to obtain the PQRS, on the top base you are going to obtain ABCD. Okay. So that means no corner is going to be just coincide with the opposite corner. Okay. So while you are going to see from the front, ABC corners are the solid lines. Okay, and this was your dotted. Why? Because this corner is not visible from the front. Okay. Okay, now tell me the points which are going to be obtained on the top base. It is ABCD. So this becomes A1 dash. So this becomes B1 dash. This is C1 dash. It is in bracket T1 dash. So here it is O1 dash, O2 dash. On the bottom base points which are obtained on XY. So this becomes your P1 dash, Q1 dash, R1 dash in bracket S1 dash. So this is the thing which you already know. Students, is it clear? Until this step, is it clear? So I just make my vertical face is going to be inclined 40 degrees to the VP, and I just put the simple position. That's it. I didn't. This was a simple position which you do in the projection of solids. I just do that. My cube having one of the vertical face is going to be inclined 40 degrees. That should be shown from the top. So I just start from the top view. So this gives you a. This is your first step. This is your second step. Okay. Next, what is the problem? He just gives inclined 40 degrees to VP. Next, now the cutting plane is going to be entered into the scene. It is cut by a section plane perpendicular to VP. Section plane perpendicular to VP. Okay, and inclined 40 degrees to HP, and inclined 40 degrees to HP. So that means your cutting plane is going to be, how it should be like? It should be inclined and it is going to be cut like this. This was the cutting plane. So your cutting plane is perpendicular to VP and it is inclined. So it is like this. This was the plane. My hand is going to be like as a cutting plane. It is cut the solid in this pattern. It is supposed to cut in this pattern. Okay. Incline 40 degrees to HP. So your cutting plane is inclined 40 degrees and make it cut this solid. Where it is going to be? Where is the point of section? At which point it cut this? He just gives it. And passing through a point 40 mm on the axis above the base. Passing 40 mm on axis above base. So I just had to remember this. So that means your cutting plane is going to be passing through that point which is 40 mm above. Okay, I just take this was total 60. So it gives 40 above the base, somewhere at here. I just take my point as the red point is going to be considered. Okay, and from this point, the section plane is going to be passed on. Let us see. It is going to be inclined for an angle of 40 degrees. So how it is represented? Thick at ends. And thin line, small line, thin line and a dot. Okay, so this was a representation of your cutting plane. So this cutting plane is going to be passing through at a height of, let us see where this cutting plane is going to be passing on. This was passing on through the height of, given it is 40 mm from the base. 40 mm from the base it is going to be passing on. Okay, and how this cutting plane is going to be represented? This cutting plane is going to be represented where it should be shown its trace. So this cutting plane is perpendicular to vertical plane. So it should be look like as a line from the front, that is nothing but it is projected and it meets the vertical plane. So it becomes its vertical trace. So this becomes, it was represented by VT. It was represented by VT. This cutting plane is represented by VT. Why? Because whenever the view is going to be shown, it should be appears as a line, or when it is projected, it should meet the reference plane. Here it meets the vertical plane, so it just becomes the trace of this cutting plane as vertical trace. Okay, student, is it clear until now? Is it clear? Your cutting plane. So cutting plane is going to be considered inclination of 40 degrees to HP is taken, and it's passing through the point on axis 40 mm above the base. And I just draw a line of 40 degrees which is passing through the point which is 40 above the base, and it is represented by VT. Now let us see, this was the important point. You just give the numbering to the, you just start giving numbering to the solid where the cutting plane is going to be come in contact. Let us see. Always you just remember, solid line is going to be have in the projection of solid also, we know the first preference is solid line, second preference to the dotted line, no preference to the axis line. The same principle we just follow here. So whenever this cutting plane is supposed to cut the solid line, we just give a point. We just give a reference point. If it is going to be dotted line, we just give the least preference. Why? Because means, so once first of all, we just give the preference to the solid lines. Give numbering, how do we write the point? Give numbering by taking the preferential order of solid line first, and then we go for the dotted line, and no preference for the, there should be no number is given for the axis line. So whenever your solid is going to be cut by section plane on the bases, on the top base or bottom base, you are going to obtain 2 points. Let us see. First of all, let us see. My point is, first of all, always start from extreme left. First point, numbering. Let us see. Always start numbering from extreme left. So that was the first consideration. Extreme left is going to be at here. Okay. Next, from here, always give the preference to the solid line. First preference to solid line. Last preference for dotted line. No preference for axis line. So when cutting plane cuts the solid on base, we will get 2 points. Okay. Okay, students. Now tell me what is the starting point. First of all, start always from extreme left. So extreme left is going to be this. So it is supposed to cut this edge. So this point becomes my first point, point 1. Second point, all of you see. So after that, we are going to be moving from left to right. Okay, left to right. Okay. So from left to right, I just start moving. I just obtain my dotted line. So dotted line is nothing but your last preference. So I just neglect it. Next is nothing but BQ edge. So this becomes 0.2. This becomes 0.2. Next one is, it cuts this top base. That becomes your 0.3. That becomes 0.3. And next, start from the itself, the start from the end point, and we just start here. So that means 3, 4. Why 3, 4, sir? You see this. BC is going to be your visible base edge. So I just obtain my point 3. And backside you are going to have your CD edge also. backside you having CD edge also. It is also going to be cut by this cutting plane. So the numbering is going to be given as second number, that is the common point as 0.4. Students, okay. So when the section of cutting plane cuts the solid on base, we will get 2 points. Why? Because in front you see only the edge BC, but on the back side you have your CD edge also, CD base edge. That is, if you just consider here A, B, C, D. If the cutting plane is cuts in this pattern, this is going to be seen, but it is cut the back side this portion also. So that point is going to be starting point from there. That is invisible point. So we just start from the invisible point numbering at there itself. It becomes 3, 4. And next, this point becomes 5. And there is no preference to the axis line. There is no preference to the axis line. Students, is it clear now? Numbering, have you understand the numbering? Okay, I just say once again. All of you see, always start numbering from extreme left. So I just start from extreme left and I just cut this cutting plane supposed to cut this point, and here it is 1. Okay. Next, I just move on left to right. So in that I just obtain DSH. DSH is dotted. So last preference is given for the dotted. So I just skip all this dotted line. Next edge is getting at your BQ. I obtain my 0.2. Next, it cuts the base. It is nothing but BC, which is visible. So it is 0.3. That's it. Is there any visible base edge cutting points? No. Next, we just go for the last preference is nothing but the dotted line. Now you see this C comma D is going to be the edge which is invisible for you. For that only, when it cuts the base, you get 2 points. Why? Because means BC visible edge is 0.3. CD is nothing but the backside edge, solid edge. How many base edges are going to having? AB, BC, CD and DA are the 4 edges. Why it is supposed to cut it? It cuts the 2 edges. What are the 2 edges? BC and CD. So BC edge point is 3. Behind the edge, behind another edge, that is CD, which is invisible. So I just start the numbering from there. It is 0.4. But the points are going to be obtained on the common point. That becomes only 3, 4. Next one is, I comes to here. Again, I comes to reversal procedure. So starting from left to right and from right to left. Why? Because I did give marking points to the dotted lines. Once I'm going from left to right, once it's completed, I again start from left to, that is right to left. So 4, again, another point is going to be dotted line, it is 0.5. And I didn't give any point to the axis. Why? Because no preference for axis line. Student, is it clear now? Is it clear? So why so many people are putting thumbs down? All of you just see the points. First of all, I just written the points there. Always start numbering from extreme left. What is the extreme left position? Where your cutting plane is going to be cut your solid, wherever it is supposed to cut, I just give the numbering. So where it is going to be cut the solid, it is first of all it is starting from the, always give numbering first to the visible solid edges, next to the dotted lines, no preference to the axis line. First point it is cut the AP edge is at 0.1. Next, moving from left to right, and after the points are completed, you come from right to left. So in this pattern, and again comes to here. You whatever the points it are going to be obtained, you just mark the points. So this is one. Next point is I am going to get your point at 5 is going to be 2. No, why? Because this was the dotted line, least preference is given. So I just go for the next visible solid line. Visible solid line point is 0.2, that is BQ. BQ is the solid line. So that means the concept is, once you, first of all, you just give the numbering to the visible solid lines. Then next, after the visible solid lines are completed, give the numbering to the dotted lines. That means imaginary lines. Okay. Further down, I just give the numbering at here. That means First preference to the solid line means solid line is nothing but your visible line. So visible lines are AP, BQ and BC. These are the visible solid lines. So AP is going to be cut at 0.1, BQ cut at 0.2, BC cut at 0.8. That's enough. Okay, solid points are 1, 2, 3 are solid points. So that means solid visible points. Okay, next. After that, next one is there any solid lines which are going to be obtained here? No. After that, I know that one of the important point is you just remember first solid bases are going to, when your cutting plane cuts the solid bases, either that base or that base, you will get 2 points. That you just remember. 1, 2, 3 are completed. Next, 4th point where it is obtained. It is cutted here. At the same time, it is supposed to cut the CD edge also. If you have your solid like this, A, B, C, D, if your cutting plane is going to be cut in this pattern, let us see. It is cut in this pattern. When you are going to see from front, this point is going to be noted as 3. But while you are going to see from front, this point is not seen. This is nothing but your 4 point. That is 0.4 at here. This was my 0.4. Next, it is going to be visible dotted line at here. It is going to be 5. Okay, students, is it okay? 4, 5 are dotted line points. Dotted or imaginary points. Is it okay now? Students, is it okay? Okay, students, shall we move to the next step? Now, once you obtain your points, okay, now you just project the points to their respective positions. Project these points to their respective positions in the top view. So let us see first of all where point 1 is going to be existed. Point 1 is existed on AP. In between AP, that means on AP edge, this point 1 is existed. So I just project that point to the at here, that becomes point 1. Next, point 2 is obtained on BQ. So I just project my point 2 at here. So this becomes point 2. Why? Because 2 is existed in BQ. So I just projected BQ. Okay. Next, 3 point is existed on BC. 3 point is existed in between BC base edge. So I just project my point to the BC. So wherever it cuts this point, this becomes your point 3. Next, 4 point is all in between C and D. 4 point is in between C and D. In between CD, you obtain point 4. Next, 5 point is obtained on DS. So you just project that point 5 at here. This becomes point 5. Now join all the points in sequence. 1, 2, 3, 4, 5, 5 to 1. Okay. So this is going to be the points, which is going to be say, how can you obtain this pointer? So when I am supposed to see the top view, which portion is to be removed? Always we know that the portion between the observer and the cutting plane is to be removed. Okay. So portion between the observer and the cutting plane is removed, and remaining is nothing but your retained portion. So the retained portion is going to be, I just let us see. So this was, so this was nothing but your retained portion. So retained portion is 1 P1 dash, S1 dash, Q1 dash, R1 dash, C1 dash, 3 comma 4 comma 2 comma 5. So this portion is going to be 5 comma 1. So this portion is to be retained and this portion is removed. Portion between the observer and cutting plane is removed and this portion is retained. And once you obtain this portion retained is 1, 2, 3, 4, 5 is going to be your retained portion. This is going to be drawn with the hatching, represented by hatching. So this hatching is equispaced, that means equispaced and inclined some 45 degrees to the XY. So this becomes your, so the section shape is going to be seen from the top, which is obtained on HP. So this becomes your sectional top view. Your sectional, this we call it as so this was, is there any sectional portion is obtained here? Section portion means represented by hatching. So that was seen from the top only. So front view, there is no section portion. This simply I just represent it as front view. This was just the front view. So this was sectional top view. Next is, he just asked to find the true shape of the section. How can we obtain the true shape? So simply, students, have you understand up to here? Have you understand? Okay. So there was a sectional top view which is going to be obtained below XY. So once ever whatever the points which are going to be obtained, I just projected to the original positions and I just all the points, join all the points, and this space is represented by the hatching. So that gives as your sectional top view. This is just the front view. Now my requirement is to obtain the true shape of the section. So how can we obtain the true shape? So that means simply draw a reference line parallel to your vertical trace. Parallel to your vertical trace. All of you just see. So in general, if your board is space is permissible, then we can go for the on the top of the 80. If your space is permissible, generally what in the problem is going, you just draw a new reference line at here which is parallel to VT. Okay, from here you just draw the vertical projectors. But here my space is not permissible for me. I just go in this manner. Don't get confused. I just go at here. So this becomes my new reference line x1, y1. That becomes my new reference line. So from this new reference line, x1 will draw the perpendiculars from all the points on the VT to the new reference line x1, y1 like this. Okay. Once you projected these points, you just take the 1, 2, 3, 4, 5 points on the sectional copy. You just take the points from the old reference line and put it from the new reference line. Okay. So let us see. Point 1 is going to be, this was a projector. Where your point 1 is from xy, the point 1 is going to be at somewhere at here. Xy to 1 radius is taken. XY to 1 radius is taken. You just take the one projector and mark your point. Water the tune. And mark your point at somewhere here. This becomes your 1. Next, let us take your point 2, which is at here. This was the projector. The projector is going to be and you just take the distance of the 2 point from xy to here. This distance, that is xy to b1 distance, is taken as your radius, and from your reference line you just make your point 2 at here. Next, point 3 is going to be taken. This point 3 is going to be somewhere from here. I just take this radius and you just place it here. This becomes your point 3. Next, to point 4. So which is on the same projector, and you just take the distance. This becomes point 4. Next, point 5 is taken. This distance from the point 5 is the projector. Old reference line to this point 5 as radius, and you just mark this point. So this becomes your point 5. Now join all the points. Two to 1, 2 to 3, 3 to 4, 4 to 5, just see the point is going somewhere at here. This was 2, 3, 4, and 5 is to be obtained at somewhere at here. So the shape is going to be obtained as similar shape. So you just take your 5 projector and you just take this distance, which is going to be some 5 at here. No problem, you just do. So I just once again I just try to do that to obtain the shape clearly. If not, we just leave it, no problem. I'm not going for original construction. That's only the problem. Once you go for the original construction with original dimensions, then you will obtain the original shape. Okay. Next, take the distances of the point from the. So this was your one projector. The distances from the old reference line to one point is taken. Just consider somewhere it here. This is one. This was two projector. This was two. Three projector. Three. Four. Okay. So this was the shape. And you just obtained after the shape is obtained, you just do make it a hatch. Okay, so you just represent this was true shape. You just had to write it. Okay, students, is it clear now? Is it clear? The true shape is going to be obtained. Do you understand how the true shape was obtained? So first of all, you just take a new reference line parallel to VT. For VT, I just draw a parallel line which is x1, y1. Draw the perpendiculars for x1, y1 from all the points. That is 1, 2, 3, 4, 5. Draw the perpendicular projectors from all the points. Now take these points on the top few points which is on HP. So take the distances from old reference line. Old reference to point 1 is taken and place it here. Point 5 is taken and it here. Point 2 is taken from old reference line to this radius is taken and I place here. And 3, 4 points are also going to be taken and I place here and mark, join all the points. That becomes your true shape of the section. True shape of the section. Anybody having any doubt in this? If anybody having any doubt, you just type that doubt, I just clarify it. Anybody having any doubt, you just type in your chat box, I will just clarify that doubt. Everyone, anybody, any doubt, you just type in, I will just clarify that what was the point that you didn't get it. The two shape is very easy as we done in auxiliary method. Students, we just do in what we did in auxiliary method. Fifth step, what we did, we just extend the inclined line and we just draw the perpendicular projectors from all the points. Similarly, I just draw a parallel line of VT. VT is my cutting plane. I just draw the parallel line of VT and draw the new reference line X1, Y1. VT and X1, Y1 are parallel to each other. From all the points on the front view, that is, if the cutting plane points, I just draw the perpendicular projectors from all the points to the new reference line X1, Y1. So these points shape is going to be seen from the top view, right? Front view, I just see notice only 1, 2, 3, 4, 5 points. But the true shape of the section is going to be seen from the top only. That was at here. 1, 2, 3, 4, 5. This was the section portion. I just reconstruct only the sectioned portion and here. This whatever the portion 1, 2, 3, 4, 5 is to be reconstructed here to ignore the whatever the confusion or any points which are going to be. So I just ignore it to make you ignore and see the true shape of the section. I just construct here. How it is? Take all the points distances from the old reference line and put it from the new reference line. You can see this point 1 to XY distance is noted as radius, taken as radius, and take your one projector, and this was the center, drawn up to get 1. Next, 2 point to the old XY to this 2. Up to here, this radius is taken and place it from the 2 projectors. From here, I just get my point 2. Similarly, 3, 4 points are at here. From 3 from old reference line, this to this radius is taken and placed from 3. Similarly, 3 and 4 are the common projectors. XY to old reference and XY to 4, this radius is taken and this has center, draw an arc. Similarly, 5 point is at here, old reference line to 5, this radius is taken and put it from here, 1, 2, 3, 4, 5. Join all the points and make it a hatch. Okay, hatching means lines which are drawn parallel to each other with equally spaced. That is hatching. This hatching represents the sectioned shape, sectioned portion. Is it clear now? Shall we move to the next problem? Shall we move to the next problem? Can I erase this? Students, can I erase this problem? Now if we write the problem, a cube of side 60 mm A cube of side 60 mm is cut by a section plane such that true shape is a regular hexagon. Such that true shape is a regular hexagon. Draw the projections of sectional top view and find the inclination of section plane with the HP. A cube of side 60 is cut by by a section plane such that true shape is a hexagon. True shape is a regular hexagon. True shape is a regular hexagon. Draw the projections of sectional top view. Sectional top view and find the inclination of section plane with the HP. So also draw the true shape and assume all the vertical faces make equal inclination with VP and base is resting on HP. Assume all vertical faces are equally inclined to VP and base is resting on HP. So base resting on HP and all the vertical faces are equally inclined to VP. So in previous problem, vertical faces are inclined 40 degrees to HP, 40 degrees to VP. Now here it is equally inclined. That means 45 degrees inclined. Okay, equally inclined means it should be all vertical faces are inclined 45 degrees. All of you just read the problem and write the given data. So here the cube is going to be equally inclined to VP means okay. So this is A, B, C, D. In bracket it is P, Q, R, S. So this was the center O1 of O2. Height of the solid is given as height of the solid is equal to as same as the side, which is 60. Okay. So when you are supposed to see from the front, so which points are visible? A, B, C are visible. So these points are okay. So these points are going to be, this is top view, this is front view, this is O1 dash, this is O2 dash. Front view points are, in top base it is A dash, B dash of D dash. So it is a solid line, so it is also the solid. So axis line is existed, but it is hid by the this BD solid line. And this is C dash. And this becomes P dash, Q dash of S dash, and this is R dash. Okay, students, is it clear up to now? Students, is it okay? Simple position is okay? True shape is going to be seen from the top, that all the vertical faces are equally inclined for an angle of 45 degree. Equally inclined to VP means 45 degrees inclined to VP. You will obtain the simple position like this. Next, he gives the section plane where it is going to be passing on, draw the projections of the sectional view and find the inclination of section plane with HP. So how can we find it? We know that true shape is if your section plane is cut the solid in this pattern, if your cutting plane is supposed to cut the solid in this pattern, while you are supposed to see from the top, it should be appear as a hexagon. It should be appear as a hexagon. Then you simply take it as the points okay. So that means first of all, one procedure is there, standard procedure is there. All of you just see that once you require your hexagon, first of all, you just take BD as radius. Take BD as radius. BD as radius, okay, and describe a circle for BD. Describe a circle for the radius BD, B comma D. Okay. Now describe a hexagon inside the circle. How can you do that? First of all, if it is going to be the center, draw the line passing through the center. Next, this has center with side as going to be the radius. You already know how can we describe a hexagon in a circle. So we know that in geometrical constructions, we know how can we inscribe a hexagon inside the circle. You just follow that procedure. Okay. Now I just go for the procedure. So this is some one. So if I obtain a hexagon inside the circle, you will go for geometrical construction. So how to inscribe a circle with the given diameter? Inscribe a hexagon in the given circle of diameter. I just take my BD as radius, BD as diameter, BD as diameter. Describe a circle by taking your BD as diameter. This BD diagonal, this BD as diameter. Describe a circle. So mark the points 1, 2, 3, 4, some 5, and 6. Okay. And take the centers of 2, 3 and take the centers of 5, 6. Draw the vertical line. This becomes M, this becomes N. Okay, that becomes M and N. Okay, once you obtain your hexagon inside a circle, and once you obtain your MN, which is nothing but center of 2, 3 and center of 5, 6, you just draw the vertical that points 2, 3 at M, 5, 6 at N. Okay, now you just see this. So this hexagon is going to be obtained. First of all, you just take a point at the center of your, so BQ. From the center, I just take your, this center point as going to be located in the front view. Okay, in the front view, locate. This point is going to be, this point is going to be some 2 dash. All of it just see some 2 dash. Mark this point, this 2 dash. Okay. So students, is it audible now? My voice audible, right? Okay. Now 2 dash as center. So put your 2 dash point, which is at the midpoint of Q dash, B dash. Q dash, B dash is going to be considered, and let us take your midpoint as some B dash. Okay. So with 2 dash as center and radius equal to half of Mn. Half of Mn. Take the radius as half of Mn and 2 dash as center. Draw arcs to cut B dash, A dash, B dash at somewhere at midpoint at here, and Q dash, R dash at here. Okay, so this becomes your 1 dash, this becomes your 3 dash. Okay, first of all, you just place your point 2 dash, which is at center of B dash, Q dash. Mark, I just place my point 2 dash. Next, 2 dash as center, half of Mn as radius, half of Mn as radius. Draw an arc on in between A dash, B dash, and in between Q and R. Okay. Join 1 dash comma 3 dash join 1 dash comma 3 dash, which is supposed to passing through which is supposed to pass through 3 dash right here somewhere. Okay. Now if you measure the angle, you just obtain your theta. If you measure your angle between HP to 1 to 1 dash, 2 dash, 3 dash, you will obtain theta. One dash, 3 dash inclination with HP, you will obtain theta. Or simply you just don't get careful, you simply take your center of A dash B dash or center of Q dash R dash, you will just put 2 points. If you join these two, then we'll meet at here also. I just give you the what is the standard procedure. You can take directly as A dash B dash center and the Q dash R dash as centers. You just join these two, it will cut it somewhere at here. Why? Because means, so to obtain a regular hexagon, so this was the standard procedure. You can do it. Okay, directly also. Now tell me the points first of all. So 1 dash, 2 dash, 3 dash is going to be the visible points. Why? Because always start from the extreme left. Your points are going to be starting from the extreme left. This point is 1. This point is visible solid line. This is also visible base. Next, the points are going to be 3 dash, comma 4 dash. 3 dash. This is 3 dash actually. Comma 4 dash. 2 dash, comma 5 dash. And 1 dash comma 6 dash. Why? Because let us see, always start from left to right, and once it is ends, again start from right and again ends to left. 1, 2, 3 points are going to be obtained, which are going to be on the visible lines, that is A dash B dash is visible base. Next, B Q is going to be visible edge, so that is 2 points. Next, QR is going to be the visible base at bottom, that is 0.3. Next, you already have, as like the previous problem, RS is one of the base edge. RS which is going to be one of the base edge, that point is 4. Similarly, you have your edge. SD is going to be one of the edge which is not visible. Let us see, this edge is not visible. That is 5 dash. Next, AD edge is going to be behind it, which is not visible. So that point is 6 dash. Student, is it clear how to obtain the points 1, 2, 3, 4, 5, 6? Is it clear? So 1 dash, 2 dash, 3. Students, all of you just listen carefully what we. So I just have make you point out that base points you are going to be 2 points. When your cutting plane is cut the base, you are going to obtain 2 points. Why? Because one is visible edge, other is behind it. You have the all of you simply concept. Second point. Similarly, always start from the left. 1, 2, 3 are going to be points which are going to be starting from left. 1, 2, 3. 1, 2. Let us see this. 1 dash, 2 dash, 3 dash are points obtained on visible solid lines cut by section plane. Next, 4 dash, 5 dash, 6 dash are points obtained on invisible or dotted lines cut by section plane. Okay, so first of all, always start from left to right and again comes right to left for obtaining the points. Okay, students. Kati ఒకసారి టీమ్ Now is it okay? Now is it okay? Students, is it okay now? Generator అది ఆన్ చేయమన్నా పావని.
జనరేటర్ అంటే ఆన్ అవట్లేదంట జనరేటర్ వాడిందంట ఈరోజు రీఛార్జ్
Students, just wait 2 minutes. Just wait 2 minutes. Just now the power again came. Again. So if it is working in Wi-Fi, that's okay. You are going to have is going to be restarted. Students, now what is going to be the situation? Is it okay now? Okay. Students, now let us see the points are 1, 2, 3 points are going to be obtained on the visible solid lines which are starting from left. Students, for your convenience, I just once again represent you. Let us see if it is going to be your solid which is in front view like this. This was here. It is A dash, P dash, Q dash, R dash, C dash, B dash of D dash. It is Q dash of S dash. Let us see. The points are going to be obtained as, let us take the center at here and center it here and center it here. If you join these three, you will get like this. Okay. So tell me the numbering first. Always start from the extreme left position. What is the extreme left? This was the extreme left. My points are going to be here. It is one, first point. It cuts the AB edge. Next, this point that cuts, it cuts BQ. This is 2. Next, this cutting plane cuts it here. This becomes your 3. Okay. 1, 2, 3. Next, what about the next point? That is 4 point where it is to be obtained. So generally we know that whenever your base is going to be cuts the base edges, it is going to be having 2 points. Why? Because here if it is cut visibly, you are going to see R dash Q dash is the visible edge which is going to be at here. RS is the edge which is behind it, which is invisible. So always start the giving the points for the solid lines first. Solid line points are completed. 1, 2, 3. A dash B dash solid line, B dash Q dash solid line, Q dash R dash solid line. 1, 2, 3 points are completed. Now again start from the wherever it is the last point, we have to start from here. You are not supposed to go for 1, 4. 1, 4. It's not the procedure. So wherever the point is going to be get ended, you just start the consecutive point from itself. So that means 3, 4. Why? Because 4 point comes on. So I just to make your point. So 1 point is 1 dash is on A dash B dash. 2 dash is on B dash Q dash. 3 dash is on Q dash R dash. Next, these are the visible solid lines. Next, 4 dash is on, you just see R dash, comma, S dash. 5 dash is, so DS is going to be the solid line, dotted line, which is invisible. This is A, B, C are visible, DS edge is invisible. So this becomes D dash, comma, S dash. Next, 6 dash point is obtained on AD edge. That is, AB is the visible edge. Another edge is A dash, D dash. Students, is it clear now? So when you see this point like this, if your cutting line is going to be cut in this pattern, okay, if it is going to be cut in this pattern, this is going to be the, you are going to be having like this, okay. So when it is going to be cut in this pattern, let us see. So this is your solid, okay. So when your cutting plane is going to be cut in this pattern, you are going to be having your points. When you are going to be seeing from the, which is going to be like this. If your cutting plane cuts in this pattern, let us see what is going to happening is, your cutting plane cuts at this. When you are supposed to cut this point like this, at here, you see this point only, but backside you are having, if it is cut like this point and this point is seen, but when you are going to see from front, it is not so seen. Okay, let us see. A dash B dash is seen. AD edge is not seen. That was the hidden points. So these are the solid points. These are the dotted or imaginary points. Friends, is it clear now? I am taking most of the time to make you understand the concept. Students, is it okay now? Yes, that's okay now. So once you obtain your points, So in the front view, so which portion is to be retained and which portion is to be removed? Always the portion between the observer and this cutting plane is to be removed. Okay. So how can you represent this cutting plane? In general, I just draw like this, but how can it should be represented as a line, a dot, and thicket ends. Okay. So this was represented by VT. This was represented by VT. That was the section plane. Next, the retained portion is between the observer and the cutting plane is going to be removed, and this was retained. So which portion is removed? So this portion is completely removed, and this was your retained portion. This was your retained portion. Retained means existed. And this portion was completely removed between the cutting plane and the observer. This portion is removed. Now, after you obtain the points, then you just have to project the points to the respective positions. How can you project those points to the respective positions? Simply project them to its top view. So let us see. Okay, now mark the points. So one point is going to be obtained on directly, it is A dash B dash. So A dash B dash, this point becomes your 1. Next 2 point is going to be obtained on BD. So BQ, B dash Q dash directly. So this becomes 0.2. Next 3 point is going to be obtained in between Q and R. Okay, so this between Q and R. Next 4 point is going to be obtained in between R and S. So this becomes your 4th point. 5th point is on DS. This becomes 5. 6th point again it obtained on the PA. So this becomes your 0.6. Now join all the points. This becomes your regular hexagon. Once you obtain your hexagon, you just had to mark hatching. Hatching means it was the sectioned portion. Okay, so now we call this as sectional top view. This was just front view. This was just front view. This was sectional top view. Now, how can we obtain the true shape now? How can we obtain the true shape? Generally, we know that. So, draw the new reference line parallel to your vertical trace. So, that becomes, so this becomes your new reference line X1, Y1. Now, draw the perpendiculars from all the points to the new reference line X1, Y1. And take the distances from old reference line to the points and mark it there. Let us put the points. So which is going to be, so one projector, and here it is the distances from 1 to 1 point to XY is taken as radius, and you just mark this point as, all of you just mark this point as, this is your point 1. Okay, next. 0.2. So this was your 0.2. Next, this was 0.3. Next, this was 0.4. Next, this was 0.5. Next, this was 0.6. So join all the points. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Okay. Now you just do it hatching. So this becomes your true shape. This becomes your true shape. Students, is it clear? So true shape is nothing but we just reconstruct what we obtained in sectional top view clearly at here. The shape was clearly mentioned at here by taking the distances from old reference line to this point and put it from these projectors from 1, 2, 3, 4, 5, 6 projectors. Make it fast. I just give you 2 minutes and we will do one more problem, then we can stop. We will do one more problem and we will stop the today's session. Make it fast. Students, make it fast. What happened? Is my screen visible? Students, is my screen visible? So somebody had put their thumbs down. Do you have any doubt? Kindly message that. Kindly give a chat in that. Do you have any doubt? Somebody people are had left. My attendance is only 100 plus. I just seen now. So at the starting it is 150, 140. Now it is only 102. What happened? Remaining people, why are you going? Why are you lefting out from the session? So why please close it? We just discussed only 2 problems. What is your problem? I didn't understand, students. So we just did only 2 problems. So if you have any problem, you just left it. Okay. So if you have any work, you just leave it. So the people who are interested can hold on, and they just follow the problems. If you have any work, you just go. I didn't understand what was the work that you have to close the session. We just take 1.5 hours. Already the starting of the session is around 4:20. While all the people are going to be come and started at 4:20. Now it's 6:20, 6:15. At the middle of the hour, the interruption is taken place. Not hardly 1.5 hours. But you are not able to sit properly for 1.5 hours. This was a pity situation. Students, can I erase this? Shall I move to the next problem? Who is that CE for? Who is that number? Tausif, are you there? Tausif, are you there?
Sir, yes sir.
మెసేజ్ పెట్టాడు చూడండి, అందుకే 4 to 6 పెట్టమన్నాను సార్. నేను పెట్టాడు చూడాడు, ఆ నంబర్ నోట్ చేయ ఒకసారి.
ఓకే
మెసేజ్ చూడు.
ఓకే ఓకే.
పిచ్చి పిచ్చిగా ఉన్నట్టుంది వీళ్ళకి. అదే CE 3237. Tausifi, his number is 3237.
ఓకే ఓకే సార్.
Civil 3237. Students, if you have anyone, kindly go on. So interested people only be here. If you have anyone, you just leave the session. No problem. I just give you 2 minutes. No problem. Who are not interested, kindly left off this session. Anyone not interested, kindly left from this session. No problem. That's your wish. If you require the marks, you just hold on. If you don't need anything, you just go, get out from the session. Someone put a message. So, only 4 to 6 bettamannanu sir. So, who the hell are you, man? Who the hell are you, man, to say like that? 4 to 6 bettamannanu. Students who are interested, you just keep on in the session. If not, kindly left off. So are you be in the session for your sake or for my sake? If the class is going to be for you or for me? So is there any necessary to explain 3 times or 4 times the problem? 2 problems, 2 hours. We just take 2 problems, 2 hours. Is it necessary for me? Okay. Students, I request you once again, don't come for the sake of attendance. Okay. So if you are interested in the drawing session, then only please attend the session. Don't put such a irritable comments. Okay. So the comment box or chat box is only open for you for having any doubts. If you have any doubts, you just place a message in the chat box. That's it. All of you write a problem. A pentagonal pyramid, side of base 30 mm. Side of base 30 mm and axis 70 mm. Is resting with its base on HP. Resting with its base on HP. With one edge of the base. With one edge of the base. One edge of the base inclined 30 degrees to VP. And it is cut by section plane. And it is cut by section plane perpendicular to VP. And it is cut by section plane perpendicular to VP. And inclined 45 degrees to HP. And inclined 45 degrees to HP. And passing through a point mm from the base. Draw the projections. Draw the projections. Students, is it okay? So pentagonal pyramid, side of base 30 mm and axis is going to be 70 mm. Resting with its base on HP such that edge of the base inclined 30 degrees to VP. So base edge, whenever you are going to be consider the base edge, let us see. If you consider this base edge, these are the base edges. When you consider this base edge is going to be inclined, this edge is inclined 30 degrees to VP. When it is inclined 30 degrees to VP, how can you see that? When you see from the top view only, you see this inclination of 30 degrees to the horizontal. So top view gives the true shape. Okay. And how it is to be? It is drawn as draw a line of 30 degrees in such a way that one of the base edge is on one of the base edge is on 30 degrees. So this was a pentagonal pyramid. So when it is a pentagonal pyramid, so you just first of all obtain the center. Once you obtain the center, join all the corners to the apex. Okay, so these points are A, B, C, D, E, and O1 of O2. Height of the axis is given as height of the axis is given 70. Okay, now draw the projectors. Okay, and this becomes your O1 dash, it is O2 dash. So while you are supposed to see from the front, so A, B, C, D are going to be visible. A, B, C, D. B is also visible. E is invisible. Similarly, C is visible. So this is A dash, this is B dash, in bracket it is E dash, this is C dash, and this is D dash. Students, is it clear? The simple position. So one of the basic is going to be making an angle of 30 degrees with the VP. So first of all, I draw a line of 30 degrees and I reconstruct the figure of pentagon on 30 degrees. Such that one of the edges on 30 degrees. And once I obtain my top view, which is a pyramid, so all the corners are going to be joined to the apex. Okay. Next, in front, A, B, C, D are visible points. So A dash, B dash, C dash, D dash are going to be solid lines which are joining from the O dash to the points. Okay. Next one is your cutting plane. Next one, your cutting plane. How is your cutting plane? And it is cut by your section plane perpendicular to VP and inclined perpendicular to VP and inclined 45 degrees to the HP and passing to a point 35 mm from the base. So from the base, you just take the point as 35 mm, that is at center, at somewhere at here. And your cutting plane is 45 degrees inclined. That means it should be obtained like this. So your cutting plane is going to be represented by thick ends. Okay. So this represented by vertical trace VT. Now, all of you tell me the numbering. I didn't directly put you. First of all, you just see this. I just make you answer the points which are going to be obtained where your cutting plane cuts the solid. First step is always stand on the extreme left. So this was the extreme left. So always give preference first to the solid line. So this is going to be the one of the point. This is one. Next solid line is moving from this direction. So this is 2. Next, you obtain your dotted line which is not preferred. Next, it is going to be 3. Next, it is going to be 4. Next, we are going to be coming again from here. Is there any other edges which are hidden? There are no hidden edges. And next, this was the only point which is the hidden. This becomes your point 5. Once you obtain your point 5, you already know that the portion between the observer and the cutting plane is going to be removed. So that means this portion is removed and this is only retained portion. Let us see. So this was going to be your this was the retained portion and this was the removed portion completely. And now project the points to the respective positions. So one point is in between. Point 1 is obtained on OA. So project the point on OA. So this becomes point 1. Okay. Next 2 point is obtained on OB. So project that point to the point to OB. Why? Why? What happened? Okay. This becomes point 2. Next, 3 point is on OC. 4 point is on OD. 5 point is on OE. Once you obtain your points, you just join all the points. So 1, 2, 2, 3, 3, 4, 4, 5, and 5, 1. Okay. Sorry, 4 point is on okay. Once you obtain this, you just make it hatch. Okay. Now see what was the portion which is retained. This ABCD is completely retained. You see this. This was the removed portion. This was completely retained. That means ABCD is existed. So I just had to highlight you ABCD also. Why? Because it was existed. And you can also the lines which are joined 1A dash, 2, 2B, 3C, 4D are also existed. So 1A is joined, 2B is joined, 3C is joined, 4D is joined, 5D is joined. Okay. So this becomes your just front view. This was your front view. This was sectional top view. So how can we obtain our true shape of the section? You simply draw line parallel to it. I just do it at somewhere at here. So this becomes your new reference line x1, y1. All of you see here. X1, y1. So draw the perpendiculars from all the points. and place it from the old reference line. The points are going to become 1. So which is it here? This becomes 1. This is 2. 2. Next 3. Next 4. Next, this was 5. Join all the points. 1, 2. Okay. Now mark all these things with the hatching. So this was true shape of the section. Students, is it clear? Is it clear? Okay, students, all of you just copy this problem. If you have any doubts, you just message me in the chat box. Tausi, close the session. Students, all of you just copy this. So this was the end of the today's session. We will see tomorrow.